Hi everyone. Last year, there's a Chinese dude jumps off the bridge and saying, "I'm heading off first." Let's take a look at the video clip. To understand how dangerous this event is, we're going to start off by the definition of acceleration. So what is acceleration? It is the rate of the change of velocity, where delta V means final minus initial over the time it takes. Now, let's make an example. Say we have a stationary car. It takes 5 seconds to accelerate from 0 meter per second to 30 meter per second. So it's stationary means the initial velocity is equal to 0 meter per second. And unfortunately, it hits a tree. The time collision is 0.1 second. Now, for the first 5 seconds, since it's a constant acceleration, we are going to have final minus initial, 30 minus 0 over 5, which is equal to 6 meter per second, or 6 meter per second square. This means the speed is increased from 0, 6, 12, and so on. For the second part, the acceleration is going to be final minus initial. And since the time of the collision is so small, we're going to have a large acceleration in the opposite direction, negative 300 meter per second square. What is the daily acceleration we're experiencing? Of course, our gravitational acceleration or gravitational field stress. It changes, depends on location and altitude. But let's take G equal to 10 meter per second square for simplicity reason. In other words, I can express the 6 meter per second into 0.6 G and the negative 300 meter per second square into negative 30 G. Now, people are wondering how many G can they tolerate up to before they get injured? Well, in our daily life, it might be 1 to 2 G or 5 G in a fun park. There's a guy named John Paul Stepp. He is a US Air Force officer. He did an experiment in 1954 where he sits in a rocket car and it takes him 1.1 second to reduce from 508.2 meter per second to 0 meter per second. Hence, he has experienced a 46.2 G, which is quite a lot. What happened to him is he suffered a minor fracture and also a blindness for 2 to 3 hours, but fortunately, he got recovered. What caused those injuries? It's all because of inertia. Now, let's say he protect everything under his cervical spine well by tied it very tight with the back seat. But the moment the rocket car stops, his head is still moving forward at such a high speed. In other words, his spine is going to experience a lot of force. If it's not able to hold, it might break. Now, even he tied up his head well with the back seat. Do not forget, his eyeball might still traveling forward with such a high speed the moment it stops. In other words, it's like his eyeball shot out of his eye socket, which means the eye retina might fall, which caused the blindness. So before we go into the video, let's talk about how we can reduce the injuries. A thing called buffer. Imagine you are falling off, your initial velocity is equal to 0, h meters above the ground. Using the big four or solvet, you are able to use v squared equal to u squared plus 2s, where a is acceleration, s is the height above the ground. We are able to deduce the impact velocity should be equal to root 2gh. Let's make a numerical number. Say h is equal to 10 meters. And not surprisingly, g is what we just made, 10 meter per second square as well. The impact velocity will come out to be 14.14 meter per second. There are two scenarios. The first scenario is where, let's say you have an air cushion underneath the person, or he knows a bit about physics, he bent his knees, which means it's going to take him a longer time durations, say 1 second. In other words, the acceleration might come out to be 14.14 over 1 second, which is 14.14 meter per second square, or 1.4 G approximately. Now, the second scenario is where the person will drop down straight. So he does not take any protections. Yeah, he just go straight like that, which means the time of the impact should be much more smaller, say 1/10 of it. And as you guys can see, the acceleration is going to be much more bigger. In other words, the person might injure himself. Let's now talk about what happened when the person jumps into the water. Since water molecule has a strong cohesive force between them, it's a bit complicated. But after modeling, scientists are able to find the force water molecule exert on the person's body is going to be proportional to AV squared, where A is the impact area and V is the impact velocity. We have impact velocity before, which is V equal to root 2gh. And we are able to use Newton's second law on top of that, which is acceleration equal to F net over m. By combining these two together, we are able to deduce the acceleration the person experience should be proportional to AV squared over m, should be also proportional to AH over m, since we are able to see the 2g are simply constant. In other words, the acceleration depends on the impact area and the height and the mass. So if you are more fatter, which means you're probably gonna experience less injuries. Now let's talk about a real life experiment they did in a Discovery Channel called Mythbuster. So what they do is they lift up a dummy model to 50 meters and put a detector next to the head. So the acceleration is recorded once it hit the water. Say the height is 50 meters. So the area of the impact, let's say 0.1 meter square. What they recorded is the acceleration is 250 G, which is a lot. That's why the dummy model's leg and arms has been broken off. Now let's talk about what's going to happen to that Chinese dude. By looking at the video, I can see the time of the flight is approximately 2 seconds. By using the solvet, S equal to UT plus half AT squared, we are able to deduce the height is approximately 20 meters, which is better off compared to the 50 meters, right? So the acceleration of the man can also be found mathematically using the ratios, which is 20 over 50 times acceleration of the model, which is 250, which comes out to be 100 G. Bear in your mind, he might be a bit heavier than 60 kilograms. I mean, he definitely is, which means he's going to experience less G than that. But it's still a lot to take in. So all I can say is good luck to him. So does that mean human being cannot jump over 20 meters? Not really. During the 2020 Tokyo Olympic event, high diving has a height around 22 to 27 meters. Athletes are able to jump such height by reducing the impact area. As you guys can see, area is the major factor. So how would they do that? They will straighten their arms, create a streamlined figure like that. This not only reduces the injury, but also reduce the amount of the splash, hence increase their score. Thank you for watching.